Hello everyone, we are Happy Wednesday. Today we want to talk the topic about LSTM-based stock price prediction system. Next. And this is our category. Next. We conducted experiments in sequence with two different models, LSTM and MLP, utilized data from Tencent Holding to investigate the potential of AI for forecasting stock prices. LSTM models are powerful tools for analyzing time series data like stock prices. They can detect the intricate patterns and trends that might be missed by humans, thanks to their ability to understand nonlinear relationships and time-dependent behaviors. This helps analyze both subtle changes in markets, reducing the risk of loss of investors and enabling more informed investment decisions by predicting future market movements. Experts.
Our LSTM model comprises 4 layers to analyze stock price training pattern efficiency. It's take in 16 constant dates of closing price. The first 2 LSTM layers, each with 50 lots captured between the macros cross and macros curve features. Following this, 2 density layers summarize the outputs with 25 nodes in the first layer and 1 node in the final layers, predicting the 61 days closing price. Next page. To optimize our model, we emphasize the elder optimizes and minimum square error as the lowest function. Evaluate the distribution between the prediction on the ground truth data with multiple validation loss to ensure model performance, utilizing earlier stopping to prevent overfitting. During training, 20% of the datasets serve as a validation data, enhancing accuracy and efficiency. By fitting the prepared datasets using keyword built-in fit function, we iterate up to 1,000 YFinance, ensure a balance between training time and model convergence. The best one is identified based on the lowest validation loss with no further decrease for 10 constant rounds. This approach maintains accuracy while minimize training duration, but this model performance is not well, so we have the MLP models. Next page.
Okay, then I'll talk about using MLP to predict the stock trend. We know that predicting the trend of the stock market is a binary classification problem, and the model should output the bull and bear probability of the next trading day after learning the previous stock behavior. So we choose MLP because it's a nonlinear model and performs well when dealing with large-scale data. Here is our model structure. First, we have input a matrix with number of rows and columns, and then is a flattened layer. It flattens the input matrix into a vector form. Here we come to hidden layers. Each fully connected layer consists of 256 neurons. It aims the model to learn 256 simple and complex indicators. And for activation function used in hidden layers, we choose ReLU. It enables the model to handle nonlinear relationships in the stock market. Finally is the output layer. It's a fully connected layer with length of classes 2 neurons using the softmax activation function, which allows the model to output probability distributions for the 2 classes and ensures that the sum is equal to 1. Here is our training model process. For the loss function, we choose categorical cross-entropy, which is suitable for classification problems based on cross-entropy. For optimization algorithm, we choose the commonly used AIDM. And for the evaluation metric, we choose accuracy, which calculates the ratio of correctly predicted cases to the total number. And for callback functions, we have 2. The first one is model checkpoint, which automatically saves the model, and the second one is early stopping. It can monitor and stop the training process early if the model's capability does not improve after several rounds. And next part is the experimental study. Welcome my teammates to introduce.
I'm going to introduce our long short-term memory network model. Next page. The purpose is predicting the next day's closing price based on historical closing records over 60 days. Firstly, we installed the database of YFinance. holdings and select the Tencent holdings. We kept the 60 consecutive days of closing prices as inputs. Then we get a two-dimensional array. The 80% of the data are training set and the rest are test set. They are segmented from the whole data set to confirm the dimensional information of the data. Next page. Our prediction results of the model will be converted to the original stock price units by the scalar inverse. Then we will compare the difference between the model prediction results and the actual price by visual charts. Next page. Next. Here is our results. You can see the prediction line and the ground truth line do not overlap, which means the model doesn't capture a trend of the price movement. So the information contained in the past stock prices is not enough to infer next day's price. Next, my partner will introduce how we can use MLP model to make some improvements. Okay, next.
As for MLP, we want to use machine learning to predict whether the share price will rise or fall tomorrow based on the daily K charts of the last 100 days. Taking into account the complexities of the real world and the reliability of the model, we want the model to be at least 60% accurate. Next page. We use the YFinance tool to download daily share price data. After data pre-processing, we split the dataset into training dataset, validation dataset, and test dataset. Next. As we can see in the training records, although the loss function of the training dataset continues to decrease, the loss function of the validation dataset stops the decreasing trend after a few rounds and even shows signs of anti-increase. It proves that the validation dataset we use can effectively avoid overfitting the model. Next. Our model has an accuracy of about 0.51. Next. As can be seen from the metrics, there is not much difference in accuracy between the bull and bear markets, suggesting that the model is somewhat balanced. Next. The model's performance is not ideal, indicating that models like multi-layer perception may be not simplistic to capture the complex factors contributing to stock price fluctuations. However, it's important to note that this limitation could also be influenced by the subjective nature and unpredictable inherent in the stock market itself. Next.
Next page. We choose the LSTM model to predict the closing price of the stock and use the MLP to predict whether the stock price will rise or fall in the future. Next page. The results show that neither model met expectations, but compared to the LSTM model, the results of the MLP model confirmed that the key factors we considered in the experiment, including stock screens, data set allocation, and model construction, showed a significant impact. In fact, it is impossible to predict the short-term price from the past stock price. Maybe the input should contain more information. Maybe the forecast goal should be medium and long-term. In the future, we will continue to research and explore in these directions to find a more suitable model for stock prediction. Next page. This is our workload distribution. Thank you very much.